7. So rational functions. Basically, rational functions. If I say rational number, what am I talking about? No, I would have said imaginary if I was talking about imaginary. If I say what?
Wait, what's the question? What's a rational number? A rational number is.
I think somebody else said it. I think you said it. So I heard it over there. It's a fraction, basically. All right. So these, when I say rational functions, we're talking about functions that are essentially written as fractions. They have a numerator and a denominator. Now, way back at the beginning of the course, and we touched on it in trig, especially with the tan graph. If you have a rational function or a function that has a denominator, you have restrictions, right? Because what number can you not divide by? 0. So what's the restriction on the first one here? X cannot be 1. What about this one? There you go. Whoa.
Oh, that was great.
Positive or negative 3. And what about the last one?
-2.
There you go. We call these domain restrictions because they're X values. All right. They have implications of the graph. In the past, we've just said, hey, what can X not be? What is the domain restriction? Now we're going to look at the graphs and what they do to the graphs. Okay? When you have a number that is outside of, or is excluded from the domain, they are called discontinuities. Now, if you take calculus, you're going to see that word over and over and over again. Discontinuities, discontinuous, all these different things. They all mean the same thing. In grade 11, we called these non-permissible values. We're just going to call them discontinuities now. Okay? Now, not just because it's a rational function does not mean it has a discontinuity. All right? So, for example, look at this thing. What is the restriction there? Put -1 in there. What happens? Yes, it becomes positive. So, if you try to solve this, you're going to go x squared plus 1 cannot equal 0, right? If you move the 1 over, what happens to the 1? It becomes negative. Can you square root a negative? You can if you include imaginaries, but we don't know about imaginaries. So, how would you actually do it? Well, if you're going to include the imaginary system, which at university you might, but we're not going to do that. So we just say there are no discontinuities. And the trick is, if you just look at this, whenever you square a number, it's always going to be positive. And if you're adding a positive number to a positive number, it's always going to be positive. It's never going to be 0. All right. So there's 2 types of discontinuities we're going to look at in this unit. There are infinite. An infinite discontinuity is just an asymptote, a vertical asymptote. That's all it means. Okay? And then we're going to look at point discontinuities, which are holes in the graph. Sorry. Yeah, I'll call them something else when we get to them later. All right. So it's just literally that's a hole. Like a graph looks like this. There is a hole in the graph. That's all a point discontinuity is, and I'm going to call it a point of discontinuity, a POD. Oh, yeah, way better than that. All right, so we're going to look at vertical asymptotes. We're going to look at points of discontinuity. We're going to talk more about, remember, horizontal asymptotes. And I said in Math 12, until I tell you they're always 0. Well, now we're going to change it from 0. And if you go on to calculus, you will actually see that there are called slant asymptotes. And there are actually parabolic asymptotes. There are asymptotes if you do a 3D graph where the asymptote comes out and the graph just spins around it, coming out at you. We don't do those in calculus, but that's later on if you go on in university. All right, flip the page, please. Okay. Here's our function, 1 over x minus 1. What is the discontinuity or the non-permissible value, or what can x not be? 1. X cannot be 1. All right. So we know at 1, we're going to have a vertical asymptote. I'll tell you later on, we'll learn how to distinguish if it's a point of discontinuity or a vertical asymptote. But right now, at x is equal to 1, those are bad.
Why is it an asymptote?
I'll distinguish between them in a sec here. You get x is equal to 1. Because you cannot have that point. You cannot put 1 in there because the whole thing blows up. You get 1 over 0. What we want to do is what happens when we get closer to 1. Okay? Well, let's find out. More steep. All right. We're not going to do this one. We're going to do this table here. So this is us getting closer and closer to 1. All right. If I put, here's our function, x minus 1. If I put 0.5 into it, into x, can anybody do that in their calculator? Sorry? -2. Right? Because 0.5 minus 1 is negative. So I get -2. If I put 0.9 into it, what do I get? And for x, you get -10. I put 0.99 into it, I get? That's exactly what you get. -100. All right, you can't do 1. Put 1.01 into it, what do you get? If I put 1.1, what do I get? And if I put 1.5 into it, I get 2. Okay. So it has a horizontal asymptote with 0. I'll talk more about that later on. For right now, just accept it. So as we get closer to 1, when all the numbers are less than 1, so I'm coming from the left-hand side, right? What happens to my y value? Remember, this is the y value. In the negative direction, right? So the graph looks like this. As it gets closer to 1, the graph zooms down like that. I'm just going to put it as 0 right now, but later on in this one, I'm going to teach you how you find out if it's 0. As I come from the other side, what do the numbers do as we get closer to 1? They increase. Or sorry, we're moving. Yeah, as we get closer to 1, they go up. So it comes. Boom. Does it ever get to 1? No. So this blue line gets closer and closer, but it never touches the asymptote, the purple. Okay? It never gets there. It'll get really, really, really close. And it doesn't matter what numbers you put in here, 1.0000000, as many zeros as you want, then a 1. It still won't touch it, and its value will be massive. So we would say that as x gets closer to 1, I want to say y goes to infinity. Hang on. As x goes to 1, this is kind of bordering on calculus notation, but that's okay. As x goes to 1, yeah, I'm just going to use the notation. So this is calculus notation. I'm not going to ask you to repeat it on a test. As x goes to 1 from the positive side of 1, which is the positive side is the right side of the graph, y goes to infinity. It doesn't equal, it goes to. Okay?
Is the calculus notation the plus around the 1?
Yeah, it's the plus on the 1 and the arrow. So this is sort of, we're bordering on limits here, but that's okay.
So both of these we should learn if we're going to...
You're going to see it in calculus. I'll reteach it to you. I just kind of want you to understand, and I'm not going to ask you to repeat any of this on a test. I just want you to understand that as we get closer to 1 from the positive side, the y values shoot up to infinity.
It says x equals 1 to the x?
As x goes to 1 from the positive side, which is the right-hand side. So then as x goes to 1 from the negative side, right? The negative side of 1 is the left side of 1. What does y do? It goes to negative infinity. Okay? that's the sort of definition. We would put the word limit in front of that if we were in calculus. We're not, so we're not going to worry about that. But basically, I just want you to understand that as you get close to an asymptote, it either shoots up to positive infinity or it shoots down to negative infinity. Okay? But you never, ever touch the graph. All right. Let's flip the page here. Yeah, we know that. Okay. Let's look at this one. 3 over x. So, what is x not allowed to be? X cannot be 0. So the domain is x cannot be 0, XER, or negative infinity to positive infinity. That's what it means. It can be anything, it just cannot be 0. So we draw a vertical asymptote at 0. Right down the middle. X equals 0. There's our vertical asymptote. For now, I'm just telling you the horizontal is 0 as well. We're going to learn in about 5 minutes how to figure that out. So how do we sketch? We know we cannot touch the line x is equal to 0. How do you figure out, because they don't always just go like this and like this. Sometimes they're flipped. Sometimes they're on both sides. Okay? So how do you figure out which side it's on? Does it go like that, or does it go like that, or like that, or like that? So you just pick a point. You pick any point. What is the easiest point to pick? 1. And normally it would be 0, but we can't put 0 in, right? So we pick 1. Test the point. So test a point on either side of the asymptote. All right, so we're going to test x equals 1. If I put x equals 1 into the equation, I get 3 over 1, which gives me 3. So that means that when x is equal to 1, which is right there, y is equal to 3. That make sense? Okay. You have to go through this point, but you can't touch this line and you can't touch that line. What is the only thing the graph can do? Exactly. It looks like this. That's all it can do. Now, 90+ % of the time, notice I didn't say always, the graphs will be alternate, okay, of the vertical asymptote. That's not always the case. We're going to test it just in case. So what's the next easiest point to test? -1. So x is equal to -1. Therefore, y is equal to 3 over -1, which is -3. So that means when x is -1, y is -3, which is right there. You can't touch any asymptote, this one or this one. So the only thing the graph can do is, and it'd be better if I actually hit the point, so I'll just make my point bigger. That's the graph. This is all I'm going to expect you to do on a test. All right, we're going to look at labeling the x and y intercepts and stuff as well, but I'm just looking for quick sketches with the indicated discontinuities.
So sketches don't really have to be too accurate.
In terms of the sketch, I don't really care. What I'm going to look for is get the vertical asymptotes, the horizontal asymptotes, the holes, and the x and y intercepts. But you'll see it's not too hard when we do it. All right. Are we okay? All right. I want to skip ahead, and then we're going to come back to 458 because I want to talk about horizontal and vertical asymptotes. So we're going to go to this page right here. All right, this is page 472. Okay. We're going to come back to it in a sec. So vertical asymptotes are the easy things to figure out. They are just what makes the denominator equal to 0. That's it. So if you have 1 over x plus 2, and I'm gonna write vertical asymptotes as VA from now on because nobody wants to write it out because you're gonna write it a lot. So the vertical asymptote is x equals -2. It's what you are not allowed to have. It's your domain restriction. Okay. Now there is a more nuanced definition, but we'll learn that in calculus.
That says what makes no main zero, right?
Denominator zero.
Denominator.
Do you want me to write denominator, the whole word?
Yeah, I thought what makes demon zero.
Denominator equals zero. How's that? It's the demon.
What makes the demon equal?
Okay. Is that okay? All right. Horizontal asymptotes. Now, if you take calculus, you will learn the actual definition of a horizontal asymptote. For right now, if you remember these rules, you'll get it right every time. Okay? Because the definition is based off of limits, which is the first unit in calculus. So like 3 weeks from now, you'll know the actual definition if you're taking calculus. All right. Horizontal asymptotes. You got to know these rules or write them down. So here we go. If the degree, so nx, here I'll write it out. Nx is the numerator, dx is the denominator. So if the numerator, the degree, if I say degree, what am I talking about?
How hot it is outside?
If I say degree, I mean,
How much multiplied by? When you say degree, it means.
if I have this function,
It's
if I said what's the degree of that function, you would tell me 3. It's the highest exponent. Okay? That's the degree. So, if the degree of the numerator is less than the degree of the denominator, then y is equal to 0 is a horizontal asymptote. So what that means is, if I have, I don't like this example here. Let's do this one, make it clear. X squared over x cubed plus 1. Okay, so what's the degree of the numerator? 2. What's the degree of the denominator? 3. All right? Therefore, y is equal to 0. And I'm going to write horizontal asymptote as HA. All right? And if you are not sure, the easiest way to figure it out is to plug in a number, a big number. Okay? So if I put 100 into here, I should do it on my calculator. Say 1,000. Say I put 1,000 in there. And I get 1,000. That's too big. Divided by 1,000 cubed plus 1. I get 0.001. Okay, which is getting really close to 0. Okay, so if you're not sure, just plug in a really big number. Because if you take calculus, you'll find out that the definition of a horizontal asymptote is what does the graph do as x goes to infinity. When x gets really, really big, what is the graph getting close to? Okay, but that's calculus. So you just have to remember, if the bottom has a higher degree than the top, it's 0. If they are the same, all right? If the degrees of the numerator and the denominator are equal. In this case, the degree of the numerator is 1. The degree of the denominator is 1. You look at the leading coefficients. Okay? So, why are we not writing? HA. What's the leading coefficient of the numerator?
2.
What's the leading coefficient of the denominator?
1.
So my horizontal asymptote is 2. Okay? And the last one, which you, in this class, I would just say what, I will never ask you to graph it, but I will say, if the numerator, in this case x squared, has a higher degree than the denominator, there is no horizontal asymptote. No HA. Because what happens is, if it's a degree greater than 1, like it's a 1 degree higher, you get a slant, or an oblique asymptote, it's a line. If it's 2 degrees higher, you get a quadratic. And if it's 3 degrees higher, you get a polynomial. These are all the different asymptotes you can have. Okay?
We'll learn about all of these.
That's later on in the course. That's later on in calculus and stuff. All right, so there's no horizontal. Remember those rules, okay? You have to know those rules. Go back to page we were on. This page right here. 470, please. All right, so now I'm going to say on a test, sketch this graph. Okay? So this is page 470. So the first thing you do is what is the domain restriction? What is x not allowed to be? X cannot be -1. Therefore, my vertical asymptote is x equals -1, right? Because a vertical asymptote is what makes the denominator 0. So mark the vertical asymptote. Oh, I marked it at 1. All right. Then, what is the equation of the horizontal asymptote? HA. Yes, so you look at the degree. The degree of the top is? The degree of the top is? 1. The degree. What's the degree of the numerator? 1. Therefore, you look at the leading coefficients, which is 2 over 1, which is just 2. Your horizontal asymptote is at 2. There's your HA. And your VA. Okay, so we got our asymptotes. Now, you test points. Okay? What's the easiest point in the world to test? Nope. 0. If 0 is in your domain, that's the easiest point. This point right here. So if I put 0 into this, what do I get? Let me do it at the bottom here. So if I test x equals 0, I get y is equal to 2 times 0 over 0 plus 1, which is 0 over 1. Can you do that? You can divide. 0 by anything is 0. So there's a point at 0, 0. Now, if you can't touch a vertical and you can't touch a horizontal, what's the only thing the graph can do? So it's going to go up like that. Now, for Math 12, I'm going to say you cannot touch a horizontal. Okay? That is not totally true. All right? Later on in calculus, you'll see you can cross a horizontal as long as it's close to the origin, because the definition is what happens as x goes to infinity. We're not going to see any of those. So for you guys, you people, you can never touch the horizontal. Okay? You never can touch a vertical no matter what. All right? Okay, so how do I figure out where the rest of the graph is?
You just plug in another point.
On which side? The left side of the vertical, right? Or the vertical asymptote. So I'm going to test x is equal to -2. If I do that, I get, what's this equation? 2 times -2 over -2 plus 1. -4 over -1, which is 4. So at -2, we're at 4. Therefore, the graph has to look like that. How's that? That's it. That's all you have to do for that graph.
Like how would we know if it was false? Like if that wasn't within the like when we tested them, what would it equal? That would show us like if I put in
I don't totally understand.
-4, like I know that would.
You can do -4. If you do -4, the point is you're going to get a number that's above the horizontal. So you know, like -4 would be right there. So as long as that point is above the horizontal, and I've told you you cannot cross a horizontal for this class, the only thing the graph can do is that, because you can't hit either one, right? You can't draw the graph like this. I'm going to erase this. You can't draw the graph like this, because then you're running into them, right? So you can't, the only thing the graph can do is that sort of swoopy thing.
And this is for math, right?
It'd be for Math 12. For Math 12, that's what it is.
Yeah. For calculus.
Yeah, it's down the road.
Like how do I know that the asymptotes are in those quadrants and not in the other quadrants?
Because a vertical is what makes the denominator 0, and a horizontal, you have to look at the leading coefficients. Or sorry, the degree and stuff. All right? All right. We're finishing up lesson 1 right now. Here's the last question. We're going to sketch this function. All right? Algebraically determine, whatever, we're sketching this. sketch. Okay. Now, if I ask you to sketch something and it's written in polynomial form, the very first thing you have to do is what? You got to factor it. You have to factor top and bottom. Okay? All right. So, what is the top factor to? 3 and 2. So the top factor is the x plus 3, x plus 2. The bottom, I'm just going to give you the answer. We did a whole bunch of this factoring in Trig 2, so you better know it by now. Turns into 2x minus 3, x plus 1. Okay, there it is in factored form. Now, I'm going to add, so we can do right away, we can do the vertical asymptotes. Leave some space over here where I wrote sketch, because we're actually going to sketch this graph, okay? So what are the vertical asymptotes? What's the definition of a vertical asymptote?
So it's like, is it like -1 and then 3 over 2?
Oh my gosh. Vertical asymptote is what makes the bottom 0. You're right. So x cannot equal -1 or positive 3 over 2. You can have more than one vertical asymptote. Okay? This is why we write them in factored form, because then you can see what makes the denominator 0. All right? Does everybody understand how I got -1 and 3 over 2? All right. So what's the horizontal? Now, for the horizontal, it's easier to look at the original. Okay, because what are we looking for?
The exponent?
The exponent. So what's the degree of the top?
2.
What's the degree of the bottom?
2.
Okay, so we look at the leading coefficients. What are the leading coefficients?
1 over 2.
1 and 2. So the horizontal is y is equal to 1/2. All right, does that make sense? No. Not in this class. No, you would have, if you have a square root, you can have 2. Because you have a positive root and a negative root. So as it goes, it can go to this one up here, and then a negative one can go to this one down here. So it would only be on 1/2 of the graph, but that's not this class. Okay. So y is equal to 1/2. Does everybody understand that? Those are those 3 rules, these ones right here. You have to know those rules. One's right above it. Okay, so we got our horizontal, we got our vertical. Now there's 2 other pieces of information we can get from this graph. The first one is x-intercept. All right, how do you find the x-intercept? What zeros? Put 0 in for y. Okay, sorry. Now, you don't actually have to do any math if you have it in factored form. Because, here's an aside. If I have this, so essentially what I'm going to do is I'm going to get this. I'm going to write it out. But if you think about it, you save yourself a whole bunch of time. No. All right. If I have this equation right here, how do I solve that? This purple one up here. How do I solve that? You're going to, the fast way is you'd multiply that up, right? What's 0 times anything? 0. So really, what do you end up with? 0 is equal to x plus 1, right? Does that make sense? So so when you have a numerator and denominator, the only thing that can make it 0 is what's in the numerator. Those are your x-intercepts. So what makes this bracket 0? -3. What makes this bracket 0? 2. Those are your x-intercepts. If it's written in factored form, you just look at the numerator. Okay? So your x-intercepts are x is equal to -3 and 2. There's your x-intercepts. All right. Remember, the denominator tells you the vertical asymptotes. The numerator will tell you the x-intercepts. How do you find the y-intercept?
Sub-zero into F?
Now, that's the easy one. And for that one, you want to look at the unfactored form. Why do you want to look at the unfactored form? But why is it easier?
Because you have numbers on your own.
It's, well, if you put x is equal to 0 into here, what's the only thing I'm left with? -6, right? And if I put x into the bottom, what's the only thing I'm left with? So your y-intercept is actually just -6 over -3, which is 2. All right? Is that okay? Now we have enough information to sketch the graph.
So you'll ask us for those.
I'll ask it for all those, yeah.
The x-intercept, y-intercept, vertical versus asymptote.
Yep. All right, here we go. So we're going to sketch the graph. We mark our vertical asymptotes, which occur at -1. Just guesstimate where that is. You will have graph paper to do this on the test. And 3/2. We have a horizontal asymptote at 1/2. Y is equal to 1/2. Okay. You've marked all your asymptotes. Now, mark your x and your y intercepts. So, x-intercepts are at -3 and 2. -3 is somewhere over here. 2 is right about there. Are we? Everybody with me? Yes, are we? Okay. Y-intercept is at 2. If our horizontal asymptote's at 1/2, that means the y-intercept has to be above it. Do you have to do any test points now? No, you don't, right? Because I told you, can you ever touch an asymptote?
No.
No. You can never touch a vertical. In this class, we can never touch horizontal, okay? So if I have to go through -3 and I can't touch either asymptote, the only thing this graph can do is that. Same with 2. Looks like that. What about the middle bit? It's a little parabola hanging out in the middle. We did it when we did reciprocal transformations. That's the graph of that function. Okay? Yeah.
And when we graph this, you want to find the arrows on the end of it.
Yeah, because it goes forever. All right. Lesson 1 is over. How do we feel?
This is Euclidean, right?
It's not really geometry.
Well, like if this sort of thing is mentioned in the elements, right?
In the what?
Euclid is Euclid's first math book.
I haven't read
I
that.
don't know.
I know what you're talking about, but I thought
There's this adage of like two parallel lines will never touch each other. On an angle they will intersect.
yeah, that's more geometry type stuff though. But yeah, I kind of understand what you're saying. Old mathematician. All right, here we go. Here's your questions. Numbers 1, A and B. Number 2, for number 2, do A, B, and D. Don't want you to do number 4. Number 4, and then that's it. All right.
Yeah,